What is a linear equation? Well, to start, I think we can talk about just the most basic linear equation there is, and that's y equals x. Now, what does this mean? Well, it's describing a relationship between y values and x values on a Cartesian plane. So we can draw our plane just like this, our x and y axes just like that, and we can label some points on here like 1, 2, 3, 1, 2, 3, and we can go in the negative directions as well. -1, -2, -3, -1, -2, -3. And we can plot a number of points on this plane based on the relationship described here. So how do we do this? Well, we can do that using a table of values. So you set it up just like this. X and y, this is your table of values where x represents your independent variables, meaning x can be anything like -2, -1, 0, 1, 2, and y represents your dependent variables because the y values are dependent on the x values. Okay, so depending on what x is, y is going to be something specific. So if x is -2, we can look at this relationship here, which says that x is equal to y, and based on that, we can infer that y must equal -2 as well. If x is -1, because they're equal, y must also be -1. If x is 0, y must be 0. If x is 1, y is 1. If x is 2, y is 2. And so this is obviously very simple to figure out, right? Because they're equal, all the x terms and y terms are the same. For more complicated linear equations, that's not going to be the case, but for this one, it just works out like that. So we can plot these points on our plane, because remember, this combination here represents the point -2, -2. If you're going to plot that on your plane, you go -2 for the x, and then down -2 for the y. You're right there. -1, -1 is going to be right there. 0, 0 will be right here. 1, 1 is going to be here. 2, 2 will be up here. And you can probably guess that -3, -3 is also a point because the x and y values have to be the same, and 3 will also be a point. And so if you do your best to connect all these points together, you're going to see that it makes a nice straight line. So that is the linear function, you can call this a function, represented by the equation y equals x. So if you're asked to graph y equals x, this is what that equation will look like. Now, what if I have something a little bit more complicated? What if I have y equals x plus 1? So before it was just y equals x, but now it's y equals x plus 1. So you have this extra 1 thrown on the end of your equation. What's that going to do? What effects will that have on our graph? Well, let's see. We'll use the table of values again to figure it out. So x and y. I'll plug in the same values for x like we did last time. -2, -1, 0, 1, 2. Those are usually pretty good terms to plug in. And then we'll figure out what the y values are. So what you have to do is plug in each one of these terms into the equation just like last time. So I'll write it out for the first one. So y equals, instead of x, I want to sub in -2 for x. So you'd have -2 plus 1, right, instead of x plus 1. Well, -2 plus 1 is equal to -1. So -1 is the corresponding y value. Do it again for -1. Y equals -1 plus 1. Well, that's equal to 0, so you get 0 here. Now you don't have to write this out for every single calculation, right? You can just kind of see what it's going to become. Like if I plug in 0 for x, 0 plus 1 is 1. If you plug in 1 for x, 1 plus 1 is 2. If you plug in 2 for x, 2 plus 1 is 3. So these are your new y values. And so now if you want to plot this on your Cartesian plane, you write your axes like that. You have -3, -2, -1, 0, 1, 2, 3, 1, 2, 3, -1, -2, -3, just roughly, right, like that. And if you plot all these points, you'll have, okay, -2, -1 is a point, so that's going to go right here. -1, 0 is a point, so that's going to go right there. 0, 1 is a point, that's going to go right there. 1, 2 is a point, that'll go right there. And then 2, 3 is a point, so that's going to go right there. And as you can see, we get another straight line, just like that. And so now this is the graph of y equals x plus 1. That's what the graph of that equation looks like. So what's the difference between this graph and the graph we drew in the last question? Do you notice the difference? It looks like this new graph has been moved up 1 unit, right? If you recall this one up here, it's crossing the y-axis here at 0, right? It's going through the origin of the plane. But if you come down here, it's crossing the y-axis here at 1. So it looks like the whole graph has moved up 1, right? Because it used to cross here, right? The line used to look like this. It looks like it's been moved up to its new location. And so what you can say is that this plus 1 here represents your y-intercept because it's crossing the y-axis right there at the value of 1. So if you see y equals x plus 2, it would represent a line that's going through the y-axis at 2, like this. That's a general rule that we can say. Alright, so that's that. Let's do another one. What if I had y equals x minus 3? Okay, well what did we just say? We said that this number represents the y-intercept. So if I want to do a sketch of this graph, just like this, doesn't have to be exact, just a sketch, what would it look like? Well, it has the same general shape. It's going up, but it's going to cross down here at -3 because -3 is your y-intercept. So it would look something like this, just as a rough sketch, right? And you could do a table of values and you could see how that works out. Another way to show that that's the y-intercept is by plugging in 0 for x, right? If you plug in any x value into this equation, it'll give you the corresponding y value. Well, the y-intercept, no matter where that y-intercept is, it'll have an x value of 0, right? Like this point here is 0, -3. If it was a line that was going like this, up here at 2, that point would be 0, 2, right? Because the x value of that point is 0, because it's on the y-axis. So if you plug in 0 for x, y equals 0 minus 3, you get y equals -3. That's the reason why we can just say, oh, that's the y-intercept, right? And so no matter what number you have here, that's going to represent your y-intercept. You can plot that point and then draw your line. Okay. What about the x-intercept? Right? Because we've been talking about the y-intercept, but what about the x-intercept? Where's that? Right, that's the point that's here, that's crossing your x-axis. How do I find that? Well, at that point, you know that the y value is going to be 0, and your x value will be some number. Right? We don't know what that number is. That's what we're trying to find. But the y value is 0 because it's not up here or down here. It's right on the x-axis, right? It's at a y value of 0. And so we can plug in 0 for y to find the x-intercept. So to find the x-intercept, all you have to do is set y equal to 0. So 0 equals x minus 3. Solve for x. You can move the 3 to the other side. Get 3 is equal to x. And so your x-intercept here is 3. So this is the point 3, 0. And that's something you can do for any type of equation. If you want to find an x-intercept, set y to 0, solve for x. If you want to find the y-intercept, set x to 0, solve for y. That's something we'll be doing over and over again. You'll get lots of practice doing that. Okay, let's do another example. What if I have something like y equals 2x? So now I have a 2 being multiplied by the x instead of a number added to the x. What does this represent? Well, let's figure it out. Let's do a table of values, and we'll see what happens. And we'll use the same x values, -2, -1, 0, 1, 2. And what are all the y values going to become? Well, you have -2 times 2, that's -4. -1 times 2 is -2. 0 times 2 is 0. 1 times 2 is 2. 2 times 2 is 4. So you get all these points. So let's draw our plane again. X, y, 1, 2, 3, 4, -1, -2, -3, -4, 1, 2, 3, 4, -1, -2, -3, -4. I'm not going to write all the numbers just because it's going to save some time. So let's graph this, right? So at -2, you're at a height of -4, so you're way down here. At -1, you're at a height of -2. At 0, you're still at 0. At 1, you're at 2. And then 2, 4. So up here. So you get a line where if you connect all these dots carefully, You use a straight edge when you do this. You get a line that looks like that. Well, if you recall, the very first one that we did, the y equals x, looked more like this. It had a 0, 0, but it had a 1, 1. It had a 2, 2, right? Negative 1, negative 1, negative 2, negative 2. The original y equals x looked more like this, right? This was y equals x. This one here, the new one, is y equals 2x. So what happened? Well, it's going up a lot faster, right? Like the original, it's like, okay, imagine you're walking up a hill like this. Not too hard, but imagine you're walking up a hill like on this one. It's a lot steeper, right? I think steeper would probably be a good word to use to describe this new graph compared to the old one. Right? It's a lot harder to walk up. And so what is that property? What would we call that? Well, what we're talking about is the line's slope, right? We're talking about the slope of the line. And so how can you quantify your slope? How can you describe the slope using a number? Well, the slope, and we'll commonly use the letter m to represent slope. I know you think maybe we should use s, but it's commonly m. The way you quantify that is by doing your rise divided by your run. You say, well, what's rise and what's run? What does that mean? Well, rise is just from any point to another point, the height difference between those two, and the run is the length between those two horizontally. And so if you say rise over run, it's like how much are you going up for every amount that you're going over, right? And so if you were going to think about this new line that we drew here, if you want to take any 2 points, you can take these 2 points that I circled, right? This is at a height of 4, this is at a height of 2, so it went up 2 units. Now how far did it go to the right? Well, it went from 1 to 2, so it went over 1 unit to the right. So rise over run for this new graph would be 2 over 1, right, which is equal to 2. So it has a slope of 2. Well, look, there's a 2 in your equation, right? Y equals 2x. And so we can say that this number here in your equation, the number multiplied by x, represents your slope, right? For y equals x, the original one, it's y equals x. There's no number in front of the x. It's just a 1, right? Remember, there's always a 1 in front of every variable. And so you have 1 times x, so your slope for this one, your slope for the original is just equal to 1. And that makes sense because every time you go up 1, you go over 1, right? From 1 to 2, you're going up 1 and you're going over 1. So 1 over 1. So your slope is just 1. So the bigger the slope, the steeper your line is going to be. So this is getting a bit crowded. Let's go to a new page here. And let's say I have something like y equals negative 3x. Okay, so negative 3, what is that? Well, if you want to imagine it this way, if you're thinking of a negative slope, that's like going downhill. So if your original function looks something like this, y equals x, y equals negative 3, it's negative, so it's going down instead of going up, but also 3 is a lot bigger than just 1, so it's going to be much steeper. It might look something like this. Still going through the middle, but it's going down very, very quickly. Okay. If you have y equals 10x, that's very, very steep, but it's positive. So you'd be going up very, very, very quickly. Perhaps something like that. So that could be y equals 10x. This one here coming down is y equals negative 3x. So if you wanted to just do a quick sketch in relation to the original function, you could show that something is steeper or that it's going the opposite direction, right? Something like that. Just a recap of how we can find the slope if you needed to calculate it. If you have the equation, obviously you can take it from the equation, but if you have a graph and you have a line, just do a random line like this, and you have a point here, say that's at negative 5 there, obviously is at a height of 0, it's your x-intercept, and then you have another point over here, which is at, I don't know, 6 at a height of 10. Again, just 2 random points on your line. If you want to figure out the slope of this line, you just use those 2 points, right? You can use any 2 points, you'll get the same answer, but let's say you know those 2 points, what they are. You can use those 2 points to figure out the slope. So the slope is equal to rise over run. Rise over run. So what's the rise? Well, your height at the first point here is at 0. How much does it go up? Well, it goes up to a height of 10. So your rise is going to be 10. Now what's the run? Well, how much did you move to the right from this point to that point? Well, you moved 5 and then 6, right? So this total length is going to be 11. So your run would be 11. So your slope is 10 over 11, right? That's your slope. Okay. Another way to do this, if you want to show the calculation, you could say your slope is equal to y2 minus y1 over x2 minus x1. This is the exact same thing as what I did here, except we're going to show the calculation. So when I say y2 and x2, what I mean are the y and x values for the second point, the point more on the right. This point here is 6, 10. This point down here is negative 5, 0. And so that's your x1 and y1 values. And so, okay, y2 minus y1, so 10 minus 0. x2 minus x1, so 6 minus negative 5. 6 minus negative 5. Well, minus minus becomes plus, so on the top you're just left with 10, and on the bottom 6 plus 5 is 11. So see, you get the exact same answer. So if you'd like to do that calculation, you can, right? You can remember this equation if you want, or you can just look at the 2 points and then measure on the graph and say, oh, it goes up, 10, it goes to the right 11, and then that's your answer as well. So however you want to do it, however you're comfortable. Now, just as one final thing, let's talk about the general form of the linear equation. Y equals mx plus b. So b is that number added on the end that represents your y-intercept. And the m value, as we just said, represents your slope. So this is the general form of any linear equation that you have, where if you were going to draw it like this, your b value would be this value here, where it crosses the y-axis, and your slope, m, is just the rise over run between any 2 points. If you can find those 2 pieces of information from a graph, from an actual drawing or sketch of a graph, then you can create the equation. And the opposite's also true. If you have the equation, you can make the graph because you know the y-intercept and you'll know the slope. Let's do one example where we have both a slope and a y-intercept that we have to account for. Let's say it's y equals 3x minus 2. So how could I graph this? Well, there's 2 different ways. You could make a table of values and then just plot all the points. But let's say we don't want to do that. Let's say we want to figure it out just by graphing it. Okay, so negative 2 is the y-intercept. So negative 2 right there. You also have, negative 1, 1, 2, 3. You always want to make sure when you're graphing these you scale it all accurately, right? Negative 1, negative 2, negative 3. Okay, so what do I do from here? Where do I go from this point? Because that's just 1 point. I need a bunch. Well, the slope is positive 3, meaning that it's going to go up 3 every time it moves over 1. Okay, so if I go 1 to the right, it has to go up 3. 1, 2, 3. So you're going to be up here. If you go over 1 again, you need to go up 3 again. 1, 2, 3. So it'll be up here at a height of 4, kind of going off the graph, right? If you go to the left one, you're going to go down 3, right, to continue this pattern. So if I go to the left one, you go 1, 2, 3. So you're like way down here. So to graph this, you can connect these lines together just like this, right? Because you go over 1, up 3, over 1, up 3. From this point to this point, over 1, up 3, right? So that pattern continues. It's like kind of a step, right? Like a set of stairs. It's the same pattern over and over and over. So if you don't want to do a table of values, you can start from your y-intercept, plot that point, and then find the next point and the next point, and just keep going in both directions until you have a nice pattern here that you can connect all the dots with and draw your line.